Hello viewers, in today's session we are going to discuss another important problem from beta and gamma functions, and in this session we are going to evaluate this integral that is from 0 to 1 and the integrand is x raised to 10, and here we have natural log of x, right? So here we are going to evaluate this integral, say I, with the help of the concept of gamma function. And here we are going to use an important result from transformation of gamma function, right? So let us first see how we can use the concept of transformation of gamma function to this integral. So now let us first define a gamma function. So gamma of n is defined by this well-known integral, that is 0 to infinity t raised to n minus 1, and here we have e raised to minus t dt, right? And the transformation of gamma function gives us this important result, that is the integral 0 to infinity, and we have here t raised to n minus 1 e raised to minus at dt gives us gamma n divided by a raised to n, right? So this result is known as a transformation of gamma function, right? So this is the definition of gamma function, and here we have the transformation of gamma function, and this result is going to be used to get the value of this integral. So now let us try to express this integral into this form, right? And here we are going to make use of the method of substitution. So here we'll take this substitution, that is the natural log of x is equal to minus t, right? So here I will make this substitution, and the natural log of x is equal to minus t, so that x can be written as e raised to minus t, right? So we'll make this substitution over here. Now here the limits of integration vary from 0 to 1, right? And here we can calculate the corresponding values of t when x is equal to 0 and when x is equal to 1. So now when we take x is equal to 0 in this expression, then we can see that logarithm of x is not defined, right? Because the domain of the log function is the set of positive real numbers excluding a 0. So here we'll take this limit, that is when x tends to 0 positive. 0 positive implies that we are approaching towards x is equal to 0 from the right of x is equal to 0. So when x approaches to 0, then logarithm of x, it tends to minus infinity, right? And this is quite evident from the graph of natural log of x. So when natural log of x tends to minus infinity, then from here we can see that t should tend towards infinity, right? So when x tends to 0, then t tends to infinity, right? And when x is equal to 1, then obviously the value of t is equal to 0, because natural log of 1 is equal to 0. So now we can write this integral I in terms of t. So here the limits of integration are from infinity to 0, because when x is 0, then t tends to infinity, and when x is equal to 1, t is equal to 0. And here we have x raised to 10. So here we have e raised to minus t raised to 10, and for natural log of x we have minus t, and for dx we can now differentiate both sides with respect to t. So we can now write dx over dt is equal to d by dt of e raised to minus t. So here we have e raised to minus t, and here we have the derivative of minus t as minus 1 with respect to t using chain rule. So here we have minus e raised to minus t. So we can now write dx is equal to minus e raised to minus t and dt. So here for dx we can now write minus e raised to minus t and dt. So now let us simplify this expression. So here we have the integral from infinity to 0. Here we have e raised to minus 10 t, and here minus and minus when multiplied together it becomes positive, and here we have t raised to 1, and here we have e raised to minus t dt. So now let us interchange the limits by taking a negative sign in front of the integral. So here we have minus, and here interchanging the limits we have 0 to infinity. Here we have t raised to 1, and here we have minus 10t, and here we have minus t. So we can add. So here we have e raised to minus 11 t, and here we have dt, and here we have used this property of definite integrals, that is a to b f of say t dt is equal to negative of the integral from b to a f of t dt. So when we interchange the limits, then we take a negative sign over here. So here now we have this integral. So we can now express this integral like this, that is minus 0 to infinity, and here t raised to 1. So t raised to 1 can be written as t raised to 2 minus 1, right? Because now we have to express this integral into this form. So we have t raised to 2 minus 1, and here we have e raised to minus 11t and dt. So now we can see that this integral is exactly of this form, and if we now compare these two integrals, then the value of n is 2 and the value of a is 11, right? So the value of this integral is now equal to gamma n. N is 2, and here we have a raised to n. So here we have 11 raised to 2. So we have minus 1 over 121, because the value of gamma 2 can be written as 1, because we know this relation gamma n plus 1 is equal to n factorial, right? So here gamma 2 can be written as gamma 1 plus 1, that is equal to 1 factorial, that is 1, and here 11 square is 121. So the value of this integral is equal to minus 1 over 121. So